Hi, everyone. I'm Jennifer Petoff, and I'm delighted to be here with you virtually today at the SRE Summit Canada. And today I'm going to talk about 10 key lessons that we've learned in the 20 plus years of practicing SRE at Google and go through some themes that have emerged throughout these lessons, which cover areas like SRE culture, operations, and change management. Let me start by introducing myself. Hello, my name is Jennifer Petoff, aka Dr. J. My nickname is Dr. J because I have a PhD in synthetic chemistry. I also like sports, that just seemed to make sense. I currently lead the global Google Cloud Platform and Technical Infrastructure Education team at Google. We're a training team that focuses on scalable learning programs for an organization spanning thousands of engineers. So SRE EDU and perpetuating the site reliability engineering culture at Google is a key part of my remit. Outside of Google, I'm probably most well known as one of the co-editors of the SRE book that we published in 2016. Fun fact for our virtual hallway track, I'm also a part-time travel blogger at Sidewalk Safari, so it's a shame I can't be there with you in person today. Love visiting Canada, and I have a minor obsession with photographing doors. That's my other weird hobby. Do with that what you will. All right, so let's get into it. So Ben Traynor-Sloss, the vice president of 24/7 engineering at Google, is known for saying that SRE is what happens when you ask a software engineer to design an operations function. So you sidestep this problem of dev versus ops by creating a discipline to balance the sometimes competing concerns of reliability and feature velocity. It turns out SREs come from many different backgrounds, but they all have this mix of software engineering and systems engineering backgrounds. We know how to both build and run systems and care deeply about both sides of the equation. So Google SRE is a central organization that takes care of many different product areas, from user-facing products like search and YouTube to internal infrastructure like our network or developer tools. And the concepts of SRE that we've practiced at Google have been tested, applied, and adapted to many different contexts. So one of the reasons SRE was and continues to be so successful at Google is that we've established an SRE culture around a good stewardship of production. So if you believe the well-known quote that's often attributed to Peter Drucker, culture beats any amount of strategy. Culture eats strategy for breakfast. So in this talk, I'll introduce you to 10 lessons that we've learned over the multiple decades that SRE has been practiced at Google. All right, so the first lesson is that we can't take reliability for granted. It's easy to forget all about reliability when things go well. However, when a system has become noticeably unreliable, already a lot of things have gone wrong. It often takes a long time to work your way back to a sufficient level of reliability. And during that time, your users, your feature velocity, your engineers, and potentially your business will suffer. Your product, in some cases, may not make it to the other side of that journey. So that's why it's really important to have a voice at the table, beating the drum about reliability at all times, rain or shine. And that's the role that SRE plays at Google. As the Google SRE motto goes, hope is not a strategy, so it's important to think about and plan for reliability right from the start and not attempt to bolt it on after the fact. This simply doesn't work, or at the very least, it's very expensive to make reliability an afterthought. So a common approach, which is also a core tenet of DevOps and is also practiced at Google, is to shift left on reliability. That is, build it in early to the development cycle. It's really easy to revise a decision while you're still drawing on a whiteboard, but making significant changes in the name of reliability gets increasingly harder once you start implementing software, let alone launch a service and have users actually start to rely upon it. Excuse me. So the second lesson we've learned is that standardization and uniformity really pay off in the long run. And when you want to scale services and when you want to scale the SRE function itself across a range of services, this is really key. So a common metaphor that we bring into play is cattle versus pets, which is often used to compare, a machine that is gently maintained through manual action by human operators to a pet, which has a name, to which we attribute some sort of personality, and which is expensive to keep both happy and in good health. And I'm sure many pet owners, as well as sysadmins, will confirm. And the thing is, this approach doesn't scale well to many machines unless you also hire a proportionate number of operators or pet owners, as the case may be. Cattle, on the other hand, are often not viewed as individuals, but as a herd, which is somewhat uniform, and each member is identified by a running number. And this is somewhat similar to maintaining a fleet of identical machines through automation and orchestration, significantly lowering the maintenance cost of each machine and making the fleet more economical to run. Of course, machines are even easier to standardize than a living, breathing animal. This is an analogy, not an endorsement, but to take the importance of standardization even further, standardization is not only important for the machines themselves, but also the services running on those machines. It removes cognitive load from operating production. So if all services, for example, if they use a standard rollout procedure, SREs don't need to remember the intricacies of the various services they're responsible for. So at Google, we're approaching standardization strategically through horizontal efforts focused on production convergence or production platform. So another important principle we have established early on is to assume that everyone is competent, well-intentioned, and will make the best decision possible based on the imperfect information that they have available at the time. It's therefore unproductive to seek to blame individuals when things go wrong. Instead, ask yourself, what were the circumstances that led to someone making an imperfect decision? Humans will make mistakes, human error. There's no point in attempting to fix people. Instead, look for ways to fix the systems and processes to make this human error less likely and less consequential. What's great about this, while humans can only learn from their own mistakes or those of others they've witnessed, systems can learn from everyone's mistakes. So at Google, we learn from incidents by way of postmortems, which are documents written after significant incidents, with the goal of learning from that incident and taking concrete actions to make it much less likely to be repeated in the future. And postmortems are only useful if they're entirely blameless, not asking who did it, but what led to the circumstances that allowed the incident to happen and how we can improve those systems and processes to avoid them in the future. Excuse me, getting over a little bit of a cold, unfortunately. So this principle of blamelessness is a subset of the more general value of psychological safety, which is critically important for a culture of learning from failure. So if there is a culture of shooting the messenger and people expect to be called out or even worse, punished for mistakes, they're only going to attempt to hide them. And this helps no one, as we can only improve if we have the most complete information available. We want everyone to feel comfortable coming forward, voicing concerns, admitting mistakes without fear of consequences. Problems swept under the rug are prone to accumulate and to also get repeated. So another core principle of SRE is that of establishing and defending meaningful service level objectives, or SLOs. And a prerequisite for meaningful SLOs is having metrics that matter. You need to agree on measurable goals that reflect your user's experience and what they care about. So most likely those things aren't that easy to measure. Things like CPU load or disk fullness. And the guide for choosing what to measure should be your user expectations, either implied or expressed, rather than the current performance of the system. You can only targetedly improve what you measure. So anything that isn't measured is likely to get worse without you noticing. SREs shouldn't be too dogmatic about this, though. So launch and iterate. Don't block on trying to get everything perfect from the very start. Only once you have metrics, you can observe, evaluate, and evolve them. And learn from them and evolve them. So as highlighted in the quote from SRE's founder, Ben Traynor-Sloss, at the beginning of the talk, SRE is not an ops function, but really a software engineering approach to production management. Still, operations are part of what SRE is doing, and let me explain why. So part of that responsibility usually is staffing an on-call rotation. However, again, on-call is not the purpose in and of itself for SRE. It's a means to an end. So SREs need to be on the front line of production incidents so they can observe a system's failure modes, learn from them, and make improvements. So everything always works great in theory, but it's always more complex in practice. So if SREs only learn about incidents through an intermediary, it's easy to misinterpret details, not fully understand the nuance and complexity of particular failure modes. So Google SRE has learned a lot by studying incidents over time and in aggregate and mining that data we collect from each individual incident. So even seemingly unrelated failures may be linked in some deeper or unexpected way, which needs both a broad and a deep view to uncover. So it's also important that SREs directly hold the pager to build credibility towards their dev partners and other stakeholders in the business, and not to be seen as, the smartass shouting wise words from the sidelines, the backseat driver, so to speak. So only if SREs are directly involved in incidents, receiving alerts, etc., are they incentivized to minimize the toil of incident response. However, that doesn't mean that SRE should be, the heroes of production. On the contrary, so Google SRE has a mantra of no heroes. Acts of heroism are bad. They're bad for the hero, they're bad for the team, they're bad for the system as a whole. So in a culture of heroism, people might be incentivized to not address problems until they turn into a big fire, so they can prove themselves as the hero by putting out that fire. But really, all systems and processes need to be designed such that they don't need acts of heroism, which are inherently just not sustainable. They lead to burnout, they may increase conflict, and deprive the organization of sustainable value. So Google SRE leadership goes as far as saying they'd rather see a team miss their SLA than being crushed under operational overload. So another thing to point out, the number one job of an incident responder is to mitigate the incident, not to root cause or fix it. The simpler the mitigation, the better, and because that makes it safer and faster to actually apply to the situation. An on-caller should never be left alone and must feel empowered to escalate. If in doubt, we coach new on-callers like it's better to escalate too early than too late, and pull in the help you need and that the incident requires. After all, we're looking out for our users here, and we want to mitigate and stop the pain as soon as we can. So of course, SREs always love automation, and to the extent where an unofficial goal of many SRE teams is to automate themselves out of a job. So the reality is humans shouldn't be made to do tasks that can be better done by machines, that can be better done by automation, as automation inherently scales much better than human labor. Sure, automating something does have an upfront cost. However, automation is not only about efficiency, but also primarily about consistency. Anything that needs to be done frequently or where any inconsistencies have a high cost is a prime candidate for automation and tooling support. In the long run, increasing levels of automation will free up time for more higher value engineering work, and in the ideal case, it keeps a flywheel of efficiency in motion. Experience has also shown that when you can automate away the toilsome aspects of SRE work, SREs are then freed up to onboard additional services or move on to higher value projects and services that could benefit from SRE attention. It actually helps keep SRE relevant and impactful in the long run. All right, change is constant. I'm sure you've heard this all before. I'm sure many of you agree with this statement. Change is constant in any organization that wants to innovate. And SREs play a crucial role in managing change both responsibly and safely. In fact, change is also the number one reason we have outages. Arguably, the safest thing to do is to never change a running system. But clearly, that's not an option if you want to innovate, if you want to introduce new features to your users, and frankly, if you want to stay in business. Any change does incur some amount of risk, and finding the right balance between reliability and velocity that maximizes the benefits for your users is key. Reliability and velocity are not fundamentally opposed to each other. Often more reliability can enable higher velocity and vice versa. But if it's not done right, these things can actually hurt each other. So SREs use various techniques to manage and reduce unnecessary risks, such as progressive rollouts, release canarying, fast and tested rollbacks, etc. Testing in production, it's an anti-pattern that's best avoided in favor of staging environments and continuous unit and integration testing. Deploying software should ideally be fully automated, and humans should only need to get involved if things go wrong. And ideally, not even then, for example, by using automated canary rollbacks. So builds should not only use committed source code and be hermetic and reproducible, so any changes can be traced back exactly to a known revision in the code. Similarly, deployment configuration should be version controlled and follow the same principles for rollout safety. So this is part of a practice referred to as GitOps. You should also release early, release often. However, rollout schedules should ideally overlap with the working hours of at least part of the team. A common rule is not to deploy on a Friday afternoon or at any time when only the poor on-caller would be around to deal with the fallout of a bad release. Change freezes, though they're sometimes necessary to reduce risk, are indeed a double-edged sword. They usually improve stability for the period of the freeze, which is the whole point. But that's at the price of potentially a larger and therefore riskier big bang release after the freeze is over. So just some things to keep in mind as you're thinking about change. Lesson learned number 9: outages are inevitable. The reality is that no matter how cautious we are in making changes, outages are still going to happen, and that's okay. The goal of SRE is not to prevent outages entirely. We're not aiming for 100% reliability. 100% reliability is the wrong target for basically everything. But instead, we're looking to reduce the overall cost of an outage. And a key to this are fast, effective, and ideally generic mitigations. So as I mentioned before, the most urgent responsibility of an incident responder is to mitigate the incident. Root cause analysis and a long-term fix, that's what follows afterwards, after you've dealt with the initial situation. So fast and safe rollbacks are an example of a primary mitigation strategy. SREs often follow the rule, rollback first, ask questions later. And during an incident, it's best to communicate in writing and leave a paper trail, ideally in a somewhat structured format if you can. Perhaps using an incident management tool that captures metadata automatically. That makes it much easier for someone getting pulled into an incident response midway through to catch up. It makes it easier to hand off state to another person if you need to tap out. And of course, it massively helps with writing the postmortem after the fact. So the more transparent your services and your code are structured, the easier it is to root cause over organizational or service boundaries without always having to necessarily pull in the respective owners. You don't run that risk of reading potentially outdated documentation if you can directly read the code instead. And we've learned at Google that a mono repository can be a game changer in this regard. So the final learning that I wanted to leave you with today is the danger of systems becoming overly complex and fragile to the extent that no one wants to go near them, like a haunted graveyard. So complex systems, they're harder to understand, they're harder to maintain, and they're harder to change. Arguably, complexity is a booby trap for change, and a fragile system needs constant fixing, constant attention, constant fixing. Of course, no one is intentionally planning to build an overly complicated system, but complexity is usually accidental. It usually accumulates over time, and this is especially as systems age and get maintained by different people over that course of time. You're reluctant to change code you don't fully understand, so you're less likely to refactor and simplify that code. So try to avoid accumulating tech debt, cutting corners, and letting code bit rot. Tolerating such broken windows is a slippery slope towards a haunted graveyard. And arguably, this type of tool, better understanding the code and possible changes, like AI could be a useful tool here to help keep this from kind of falling down a slippery slope towards that haunted graveyard. While the broken windows theory has proven to be a somewhat problematic theory when applied to real world crime, the point here is that if you don't take care of rotting and gnarly parts of a system's code, it's more likely to accumulate more of these problems. And it's kind of a snowball effect in the end. So strive to build the simplest possible system that meets your needs and try to keep it that way. Try and keep it up to date, try and keep it simple. It can often be harder to build a simple system with the same capabilities as a complex one, but it's a worthwhile investment. Okay, so that rounds out my list of 10 lessons Google SRE has learned over the course of the last 2 decades. So let's do a brief recap. What did we actually learn? So there are 4 common themes that emerge throughout these 10 lessons. So the first is that relationships matter. So dev, ops, SRE, product, other areas of the business, they need to work together to deliver the best experience for our users. The second theme is change. Change is needed in both our services in the form of new features for our users. It's needed in the way we work. It's needed in the form of continuous improvement that can help us make tomorrow better than today. The third theme is engineering. You shouldn't be feeding the machine with human toil, human blood, sweat, tears, or acts of heroism. Work smarter by engineering your systems and procedures, not harder. And the fourth learning is simplicity. So don't fall for the complexity trap and try and outsmart yourself. Keep it simple, keep it boring. Your team and your future self will thank you. And speaking of thank you, I'd like to thank you for your attention. And before we break and I finish up, I just wanted to say, please, if you've enjoyed this talk, if you want to learn more from Google SRE, please follow us on X, formerly known as Twitter, of course. And you can also find Google SRE publications, including all the full text of all 3 Google SRE books, as well as various shorter form publications, articles, trainings, etc., and more for free at sre.google/resources. So check it out. I think it's a treasure trove. Let me know what you think. And finally, if you want to learn more or have additional questions after the session, I am always happy to connect on LinkedIn. I'll pause here for a second if you want to scan that QR code. And looking forward to continuing the conversation after the virtual event today. All right. And with that, thank you. Thank you again for the opportunity to be here with you virtually today. And I hope the rest of SRE Summit Canada goes incredibly well. Thank you so much and catch you next time.